Alright, in this video we are going to be finding the density of a completely cylindrical log that is floating in water. So we're going to start by drawing our log. So let's say this is our log. It has some radius, there we go, R, some length, L, and then it's floating in some water, right? So here's the water level. And we're going to call everything from the top of the water to the top of the log, we're going to call this H. We'll call it our height. So from here, there are going to be some forces acting on our log. So especially the buoyant forces. So we are going to write this as the mass of the water times the acceleration due to gravity equals the mass of the log times the acceleration due to gravity. So we know that these are going to cancel. And because we're trying to find the density of the log, we need to get rid of the mass. So we're going to write the density of the water, and then we're going to do the cross-sectional area. So that is going to be all, let's change colors, all of this is what is right here. Alright, times the length, and this is going to equal to the density of the log times the area, so this is just pi r squared, times the length of the log. So we actually don't need the length of the log, we see these cancel too. So now, what we need to do from here is we need to find the cross-sectional area of the log. We're going to go and we're going to solve for this, okay? So let's take a little bit, let's think about how we're going to find that. So if you think about it, to find that, it would be, we'll keep drawing it like this. This is equal to a circle minus the top part, right? Okay, let's keep going. So the top part is equal to like this ice cream cone shape minus this. And this is called the circular sector. So what we're trying to do right here is we're going to find the area of the circular sector because we can solve that. And then we're going to subtract the area of the triangle. So we're going to kind of go backwards. We're going to find this, and then we're going to find this to get the area of the top. And then we're going to subtract the whole from the area of the top to get the area of the bottom. That's where we're going next. So let's start by taking a little bit of a closer look at the face of our circle. So, come on. If this is our radius, and this is our H, we can also go ahead and draw a radius here. Sorry, that kind of looks like an H. Let's redraw that so it's not confusing. A radius here and a radius here. And this height, this little thing right here, we can call the radius minus the H. Okay. This little part that we just drew, now I'm going to erase that. We want to find the fraction that it is within the entire circle. So is this circular sector 1/4 of the circle, 1/2 of the circle, 1/8 of the circle? That's what we're going to try and find. So to do that, we need to go ahead and label these angles. We're going to just call them theta, and they're the same because we cut the triangle in half. So we're going to have 2 theta, and that is over the total amount of radians in the circle. So that's just 2 pi radians in the circle. And then we're going to multiply that by the total area of the circle, which we know is pi r squared. There's some canceling that goes on with our 2's and with our pi's. And we have the fraction being theta r squared. But we don't know what theta is, and we're not going to know what theta is. It's not going to be something that they give us. So we need to solve for theta in terms of what we have. So we're going to be using the arc cosine. So theta equals the arc cosine, so the cosine to the -1. And we're going to do the adjacent, and that is r minus h, over the hypotenuse, which is r. So now this is theta. So the area of the circular sector is r squared times theta, which is what we just found, which is the arc cosine. I apologize for the vacuum in the background. R minus h over r. So this is the area of the circular sector. We'll call that CS. So now we need to find the area of the triangle. So to find the area of a triangle, you need to do the base times the height. We have the height. It is the r minus h, but we need to know the base. So we're going to go ahead and call these bases, that's not very straight, hold on, let me try again. I'm going to call these bases right here x. Okay, so change my color back. X squared plus r minus h squared equals r squared. And that's just using the Pythagorean theorem. So now we're solving for x. We're going to have x equals the square root of r squared minus r minus h squared. So in this next step, I'm just going to factor out the r minus h. I'm going to do the multiplication and then the cancellation kind of all in one step, and it's going to equal x equals the square root of 2rh minus h squared. So this is the base. So to find the area of the triangle, it's just 1/2 the base times the height. So 1/2 the square root of 2rh minus h squared, that's all in there, times the height, which is r minus h. But this is for one triangle, and we kind of have 2, 1, 2. So we need to multiply this by 2. So our 1/2 and our 2 cancel, and this right here, there we go, is the area of the triangle. So I'll just call that maybe AT. So now we need to find the area of the circular sector minus the area of the triangle. So, and that will be the area of the top. So I'm going to call that A top. So many different areas. So A top, let me zoom in because it won't let me write. Come on. Okay, sorry about that. A top equals r squared br cosine of r minus h over r. Is that the whole thing? Yes, okay, just making sure. So it's r top, sorry, that's the area of the circular sector minus the area of the triangle. So we're going to do minus the square root of 2rh minus h squared times r minus h. So this is the area of the top. That's great. We're almost there. So now that we have the area of the top, what we really were looking for was the area of the bottom. So we have to do the area of the entire circle minus the area of the top. So we'll call this the area of the bottom, which is what we were finding. I guess I could just call it AB. We'll do that. Less writing it out. Okay, so the area of the circle is pi r squared, and we're going to subtract pi r squared from all of the things on the top. So that's just everything that I just wrote. So I'll write it out again. R squared times the arc cosine, -1, no. It's just the same thing, copying, pasting. Okay. So now this, I'm going to go ahead and do it in green because that's what we did before. This area of the bottom is equal to this. That's what we have found. So from here, what we're going to do is we're going to multiply what we just found, the area of the bottom, times the density of the water. And then we're going to divide it by the area of the circle because we're just trying to get the density of the log by itself. So we're in the final step here. So that's the area of the bottom. What I'm going to do is I'm just going to multiply it by 1,000 kilograms. Sorry, that's 100. Missing one. 1,000 kilograms per meter cubed. That's the density of water. So this is no longer the area of the bottom. This is now everything that was on the left side of the equation. So now that we've multiplied it by the density of the water, we just need to divide it by the area of the circle. So we're just going to take all of this and divide it by pi r squared. I could have rewritten this, but this whole thing is a lot to rewrite, so we're just going to add these in here. And then this final thing is equal to the density of the log. We found it. Because that long equation that we found was equal to this times the 1,000 divided by this, and we're left with our density of the log. Thank you so much for watching.